geobyte.
Read it clearly. It is asking like this. The maximum height reached by a projectile is 64 meters if the initial velocity is halved. The new maximum height of the projectile is, as you know, maximum height, mathematical formula u square sin square theta by 2g. Okay. Now here nothing is spoken regarding the angle of projection. Assume theta is constant, theta remaining constant, g also constant. Therefore, I can say that h max is equal to some constant. This part I am marking as constant k into u square, or h max. H max is proportional to u square. Okay. Then you can write that h max in the first case dividing by u1 square is equal to h max in the second case divided by u2 square, because from this I can write that h max by u square is equal to constant. Okay. Now in the first case h max is 64 dividing by u1 square. In the second case h max for the second case dividing by, it is given that if the initial velocity is halved, u2 equal to u1 by 2, u1 by 2 whole square. Let's take the another slide. Otherwise, here itself I can write h1 64 एक minute. Otherwise, let us take the 64 by u1 square equal to h max in the second case dividing by u1 square by 4. This 4 goes up. u1 square is cancelling. 64 is equal to 4 because it is u1 square by 2. Yes. 4 h max in the second case. Right from this, I can write that h max in the second case equal to 64 by 4. That is equal to 16 meters. That is the maximum height covered by the particle for the same angle of projection if the projecting velocity is becoming half, right? 16 meters. Look at the options are not given. 16 meters. Understood clearly? Yes. Then let's take the another question, right? It is given like this. The coordinates of a particle moving in xy plane are given. X equal to 2 plus 4t, y equal to 3t plus 8t square. The motion of the particle is, different options are given. Option A, uniformly accelerated, having motion along a parabolic path. B, uniform motion along a straight line. Option C, uniformly accelerated, having motion along a straight line. D, non-uniformly accelerated. First, let us decide whether the motion is uniform or not. How do you decide whether the motion is uniform or not? If acceleration remains zero, then motion is uniform. Otherwise, motion is non-uniform, right? Because it is connected to uniform and non-uniform. For that, let's take the given condition x equal to 2 plus 4t. It is given that x equal to 2 plus 4t. From this, let us differentiate the x with respect to t. It is becoming 0 plus 4. This dx by dt is nothing but velocity equal to 4. Then, as you know, acceleration a equal to dv by dt, d by dt. 4. Differentiation of constant is 0. Here acceleration I got 0. If acceleration is 0, the motion is uniform. The motion is uniform. Okay. Then whether it is parabolic or not, right, can be decided by taking the another case, that is y equal to 3t plus 8t square. Y equal to 3t plus 3t plus 3t plus 8t square. 8t square. Is it correct? 3t plus 8t square. Yes. So here y is given in terms of t. For that, let us decide the t in terms of, right, t in terms of x. Right, here it is given equal to 2 plus 4t. From this t equal to x minus 2 by 4. Let us put that value. Y equal to 3 into x minus 2 by 4 plus 8 into x minus 2 by 4 whole square. Now here y is the function of square of the x. Y is the function of square of the x. Therefore, it is varying parabolically. Parabolic variation. Parabolically. Parabolically varying. I hope all of you clearly understood. Now look at the options. Look at the option A. Uniform accelerated having motion along a parabolic path. Option A itself is absolutely correct. Understood clearly? Yes. Let us take the another important question. Try to read it clearly. It is asking like this. A particle moving in a circle of radius r with uniform speed takes time t to complete one revolution. A particle is moving in the circular path of radius capital R. For completing one revolution, it is taking the time period t for the same or uniform speed. Okay? If this particle is projected with the same speed, the same particle is projecting with the same speed, that speed is not given, at an angle theta to the horizontal, the maximum height attained by it is equal to 4r. The same particle is projecting at an angle theta with the same speed with respect to horizontal. The maximum height attained is 4 times the radius of the circular path. Then the angular projection is the theta. The angular projection theta is then given by, you are asked to decide the angular projection theta. Okay. For that, the condition given is the h max equal to 4 times the radius of the circular path. Let me write it clearly. 4 times the radius of the circular path. But what is the h max? H max equal to u square sin square theta dividing by 2g is equal to 4r. Here u, uniform speed u is not given, but that u can be decided like this. As you know, the angular velocity omega equal to angular displacement dividing by the time taken. For completing one revolution, angular displacement theta equal to 360 degrees, that is equal to 2 pi. Therefore, angular velocity equal to, right, 2 pi by time taken given t. Okay. Then what is the relation between the linear velocity and angular velocity? Linear velocity u equal to r times the angular velocity. R times the angular velocity. Now here it is given that h max equal to 4r, but you know that h max equal to u square sin square theta by 2g is equal to 4r. Since u is known, u square equal to what? R square omega square, r square omega square. So r square into omega square into sin square theta dividing by 2g is equal to 4r. 4r. One r is cancelling. Then the rest of the part is r into omega value. Omega value is 2 pi by t. 2 pi by t. omega value 2 pi by t whole square into sine square theta dividing by 2g is equal to 4. Okay, 4. Now from this, you are asked to decide the angular projection theta. For that, now let us simplify it. R 4 pi square by t square into 2g into sine square theta is equal to 4. Is equal to 4. From that, the sine square theta value equal to 4 into 2, 8. 8 t square g, listen carefully, by 4 pi square r, or sine theta equal to sine theta, of course this 2 times 2gt square dividing by r pi square whole thing power 1 by 2. Therefore angular projection theta equal to sine inverse 2gt square divided by r pi square whole power 1 by 2. That is the angular projection. 2gt square by r pi square 1 by 2. Power 1 by 2. Look at the options. Sine inverse 2gt square by pi square r whole power 1 by 2. Option A is absolutely correct. Understood clearly? Yes.
Geobyte.